Cool. So, Phyllis, you're welcome to stay with here because I think we're going to talk about the project for the mod. What's it? Mod 4 now? It's Mod 4 project. So we'll go.
Yeah, I actually have a question about that.
Yeah.
In that project, we're supposed to use ARIMA model or whatever we would choose maybe, but I used SARIMA model, and I was thinking I just tried to do those analysis for the data set, like looking at like how many lags or mean AR, autoregressive type, whatever we did for for this lesson. But when we do the grid search for those parameters and just use them in the model, does do all these necessary to do? Like, do we need to do these? Find out how many lags we need or something like that. Should we just skip them?
So you're talking more like the like the parameters of like the SARIMA model, right? Or SARIMA Max.
Yes.
Yeah. So if you're yeah, so if you look at like the curriculum, like you said, like the grid search of like doing like your different PDQs, right?
Yeah.
And like going through it. What you will likely find for this model for any zip code you try is that if you do a grid search, most likely that every model most likely will have the lowest AIC when it has like the highest PQD, basically the highest order model it can get to. And I'll kind of talk about this in a little bit about going about this project, but the main focus of this project, you really shouldn't to focus on like the actual modeling aspect of it, in my opinion, because this is where a lot of there's a lot of other optimizations, a lot of things that you can do. A big part of it is, can you interpret saying, okay, what is going to be your best zip code for this area, for your stakeholders? Like, what is the quote unquote best zip code for your stakeholders? And say, well, that's going to be a lot of filtering before your modeling. When you get to the modeling aspect, I view this project, to be quite honest, more as like a good practice to get you familiar with the idea of modeling. Your models are probably not going to be perfect. And the way I kind of phrase this too is that if your models could be a lot better, it was relatively reasonable. Like, for example, here in full time, they have like a full week to do this, equivalent to like 40 hours to do the project. If you could do a really good job of like predicting housing prices within a week, there'd be a lot of richer people in the world. Like, as much as, like I love to say like, we're all like really great at this. There definitely would be some people who would be able to predict this a lot better. So I wouldn't stress too much about trying to get the right parameters for your model, which it sounds like that's what you're really asking, right? Saying what kind of parameters.
Yes. I mean, since there are multiple time series in this project, it's not just one time series we can spend time. But since we're going to have to filter even like down to 10, it's still a lot of thing to do.
Right.
That well, you know what? I'll wait until you explain everything for the project.
Okay.
And I don't want to just spoil things or make people. So I'll wait. So at the end, if I still have questions, I'll ask. All right.
Okay, I think that seems good, and I might answer some of the questions you're thinking about already. So
that's fine.
Cool. All right, so Andy and Jenny, just real quickly, have you guys looked at the repo for the project then? Just give me a little nod.
No, I haven't.
Oh, yeah? Okay, no problem. So definitely go through the actual part of going through like what they're doing. But the main idea here is that you get Zillow data, like all your zip codes. I think me and Jenny just were talking about this, like the median price, as likely as the median price for that zip code. And note that it's all the zip codes pretty much in the US for, I think it's like 1996 to like 2018. So just kind of be aware is that there's a lot of zip codes in here. And the idea here is that basically some stakeholder, in this case, they talk about firm, but really, you can kind of decide what exactly your stakeholder is. I think that's a good kind of practice, just kind of people have different ideas what this looks like. And they say, what is the best 5 to invest in? Like, what are the best 5 zip codes? And that best 5 can mean many, many different things to different people and different stakeholders. So for example, you can say, well, what's the highest returns, from 1996 to 2018? Maybe that's not the best thing to do. For example, maybe you want to look at the more recent returns, like say what has the highest returns from 2012 to 2018. Like that's going to give you different results than if you invest in 1996. So there's also aspects of saying, how much, quote, like risk do you allow? Like if there's another financial crisis that was in 2008, what properties likely, or what zip codes would likely do well, again, in a similar situation. So you might want to look at that kind of stuff. And this actually, to be honest, like we used to call this like the time series visualization project, because a lot of part really should be about the visualization, trying to pull out like, like how would you determine this? Like if someone to talk to you. And there's a few ways you can kind of approach this. So my suggestion is really think of this project as being like, let me determine what zip codes to look at. And then let me go ahead and try to do the prediction once I choose those, zip codes. So one thing I think people tend to think is like, oh, can I just make a prediction off of like many zip codes and then determine the best ones, which you can do. But if you do it with many zip codes, it might take a long time. 5 zip codes already is a lot to kind of go into for each individual model. And then your model also have confidence and they say, well, what is a better model between those two? I think it makes more sense for this project where really if a firm said like, hey, what are the best zip codes? I wouldn't go to modeling first. I would essentially go, let's see what they've done before, see how well they perform, and then try to predict in the future of these zip codes. So that's the way you should kind of frame this through. Just reading through here, there's going to be the technical Jupyter notebook. Remember just having that readme.md file for your repo, your blog post, and then your PowerPoint presentation. Remember this PowerPoint presentation should be geared towards people who are maybe not familiar with the exact nuances and technical aspects of data science. So making sure it's reasonable for your stakeholders to digest and communicate. And that's a big part of data science. And then of course, I think it's not on here, but also your recording of your PowerPoint presentation, which is basically a practice for you. So it should be added in here, but it's not, unfortunately. But anyway, let's see here. Yeah, so that's the basics of it. Trying to think if there's anything I missed here, kind of mentioning it. It gives them a little bit extra guidance in here, but I will talk about some of the requirements in here. So I have a little repo to kind of go through. So this is very similar, your notebook, your presentation, your video, your blog, right? So one thing I'll note about the blog, in my opinion, is that it's a little, I'm allowing more for people to kind of write what they want based around time series. So one suggestion I have is focus on one aspect of the project. That could be talking about how do you do visualization. So for example, in the curriculum, it kind of shows like, you don't want to just simply plot all the time series on top of each other because it's like, that gives you absolutely nothing, right? Like, I don't know what this is other than that, the fact that it looks like they all went downwards generally. So this might not be the best way to visualize this. So you can talk about in your blog post, say, hey, how do you visualize multiple time series? How did I find, the best time series through visuals or analytics or anything that you want to kind of pull out from there? You could also talk about the modeling aspects, like how do you do modeling? Like what things are you looking for? It should be focused on the technical. So you should have like code snippets. You should still have like kind of like you're gearing towards a data science minded person. So you can use terms like, like you can show equations. You can talk about doing plots, doing code snippets. You're not talking to a non-technical person. Okay. That's kind of the blog part. Video, we talked about before, just make sure you make a recording. Your presentation, again, really focus it towards non-technical. Your notebook for this one, I don't know if I actually wrote this one specifically. Yeah, so I'd say like things, keep it neat. One thing I would highly suggest is since you're gonna do like something like 5 zip codes, and you can do the same process over and over and over again, is to actually, what's it called? Make sure you take an effort to write functions so you don't have to repeat yourself over and over again. And you'll find yourself do that. Using for loops if you're doing things over and over on many zip codes, organizing your code and stuff like this. This will be useful. And these are things we can talk about office hours as well for next week. Overall, make sure you have a narrative. Is that like, make sure you have that markdown kind of explanation. A lot of times people do a great job like talking about through your technical notebook, but they never wrote any of it down. And it's really great to put that down because then what people like, if they come across your project, and this is true even outside of like trying to show off your project for a portfolio. But like if you're writing a report, you want someone else to like take that report, read it through, and understand why you're doing the things you're doing. So saying, oh, I noticed this thing right here. All right, I'm going to investigate further by looking at this. Hey, that's an interesting part. Put those things in your markdown cells. Yeah, so always put those parts in there. And remember, it's much more going to be a conversation. It's geared towards someone who is technical. So like still make your code clean and understandable, but remember, you're not talking to a non-technical person. It's someone who should be familiar with data science already. Okay, cool. And then presentation, my typical stuff is like, remember, keep it around 5 minutes. 8 minutes is really hot on the high end. 10 minutes is really too long. Use the rubric to help judge on like where that should be. Remember, you are the subject of your presentation, not the slides. So the way I kind of think of the slides is your slides are emphasizing the points that you are verbally saying. So really make sure you emphasize that, which means like less words, you know, your visualization. If you have a visualization, talk about the visualization. Don't just throw a graph up there and say, oh, you can see from the graph, and then move on. It's like, no, walk people through like, what do you want people to know from that graph? And remember, you're talking about someone who's non-technical. So be aware of like what kind of, you know, visualization you're doing. That's something I like to say someone from a high school standpoint can understand. So if a high schooler can understand it, you're probably in safe territory. If it's a little beyond high school, you might need to kind of lower that level to make it a little more understandable, or be able to walk someone through that part. Okay. Some general presentation stuff. I'll go through this really quickly since I've said this probably so many times going through, but each slide really should contain its own like thought and concept. So I always say, put in more slides. Like there's no fear in putting many, many slides. If you only have very little information on it, you spend like, you know, at maybe 15 seconds on that particular slide. You don't have to spend 5 minutes or 2 minutes on one slide. In fact, if you have so much information that it takes you 2-3 minutes to go over that one slide, it might make sense to split it up, because then it's a little bit easier to focus on what they're doing each time. This kind of goes with like, you know, 3 bullets per slide. These are soft rules. You can obviously break them, but these are my overall suggestions. This keeps it so you don't have so many different like bullet points going forward, where if someone just says, oh, it's a bullet point list, and not like know what thing's the most important part. If you have like at most 3, it's a little bit easier for you to say, oh, these are the 3 most important things I need to understand. Using sentence fragments. So instead of using like full sentences, is that it'll help people to be able to quickly get that information. You don't need to explain in a full sentence unless there's a definition or a quote or whatnot. People will get what you're saying, and you will be talking while, you know, they're seeing your slide and everything. And then don't forget to use visuals, but also pictures too. Keep the audience engaged. So your visualizations, obviously your plots and stuff like that, but a visualization can also just essentially just be an overall like large, I've literally have seen people put a little large number, like 43%, and that's their whole slide. And they say 43% of our customers were, you know, satisfied with, you know, this action. They talk more about it. So basically you can think your visualizations is like the emphasis that they should take away from it. So you can you can be very creative with this, you know, but just kind of the main idea is like whatever's on that slide is something that if they were to like write that down or take a picture of that, that's all the important stuff they need, not all the little details, unless they ask for that kind of stuff. Okay, cool. Any questions on that? I think I want to really emphasize this part because it's not really talked about the curriculum. I think it's an important aspect of data science since you are a communicator to your data. Okay, cool. All right, so I will talk about a little bit of this project. So one, focus on the business case. Think of like, what does the business want? What does the stakeholders want? And for me, at least, I say you can kind of adjust what you think of your stakeholders. Think of someone who would be interested in investing in homes or interested in the sales prices and the future sale prices of homes, and say, okay, this is where I'm going to gear it towards. So it could be a nonprofit, it could be more investment firm, whatever you really want to picture it as, and have that firm idea of who that stakeholder is. And this helps you in practice because it helps you gear any of your kind of like progress forward of like, what will they care about and what would they like to see? Okay, note that you don't have to do every zip code. In fact, I highly suggest not trying to look at every zip code. Really, I would say try to focus and say, what would my stakeholders want? What would they be interested in? What would gain their attention? For example, if you say, hey, like my stakeholders are in, you know, Texas. It's like, hey, like I'm not going to be looking at people who are over like on the East Coast or the West Coast or in Colorado or whatnot. That doesn't make sense for them, at least if this is what they're looking at. If you're looking at more big investment firms, I've had people say, oh, I'm going to look at different states, for example, to diversify their portfolio, and they're looking at different metro areas in the different states. I'm like, perfect. They had a perfect idea of who their stakeholders are. I had other people say, we're only looking at this Austin, like county area or something like that. And like, cool, like that is perfectly fine. You just have to have a good idea of what your stakeholders would want in this case. And that will also help you narrow it down, because there's, as you might know, there's a lot of zip codes in the US. So it's not worth looking at all of them at once. And note that there's a bunch of ways you can select this. So I'm sure all of you guys can be very creative in how you approach that. When processing the data. So I'll kind of show a little bit of Star Notebook, but note that there is some missing data. So just kind of be aware of that. So make sure a visualization, like some quick exploration. EDA isn't the full like focus of this, but you should always do a little bit of basic EDA going forward. The data is not formatted necessarily in a time series. So note that you'll have to kind of like move it into a traditional format, which the Star Notebook does have some help on that. But just kind of know that you do need to kind of massage your data to make it more compatible with what we've learned already in the curriculum. So that's a little bit new. So know that we might remove certain columns. Essentially, in the end, you're going to probably remove most columns in there. And you can use something like melt, a pandas function, to help you get that data in there. But it's not necessary. Some people find other ways to do it, but you might find it helpful. Note that the region names in the data set, so I think it's like region, those are the zip codes themselves. So note it doesn't say zip code, it says like region or something like that. And again, don't forget the EDA, but again, don't like pull your hair out trying to do EDA in this project. Like you want enough EDA to get a good feel for it, which means some basic plots, some quick exploration, what are the different values kind of going for, so you can kind of know what yourself getting into, but don't try to like go the full exploration of just this data without doing anything else. Okay, cool. Yeah. Oh, and I mentioned it might make sense to like kind of group it by metro area. So I had, for example, someone look at like the New York metro area and they pulled zip codes. And even in that metro area, there are many zip codes still. So that does narrow it down quite a bit, but there's still a lot for you to go into. And you can decide how you want to like frame this and how you want to explore. Okay. Quickly kind of mentioning, there is a starter notebook. So in the repo, if you clone it or if you fork it from here, there is a notebook, starter notebook right here. And this will kind of like give you some format. I will say is that you do not have to follow this to a T. Like there's no reason why you have to do it this way. It's just we found that some students would like a little bit of extra kind of like starting off point. Note, for example, like if I were to do this, I probably would move this like what's called the reshaping. I probably would personally move this up higher, closer to like maybe after data processing or even before data processing. So note that everyone has a different way of kind of approaching this. And so this is just one way, but you can kind of see basically, excuse me, is going through, I would say like, start off with saying, hey, what is your business case? And then say, okay, let me load the data itself. Maybe do some data processing, right? So that might include changing it to a different format. And then doing your EDA visualization, trying to find out what would your stakeholders really care about. So kind of like pulling that information out. And there's a few ways you can do that. But one simple way is literally just to do visualization, say what looks essentially a decent one. And note, even saying just plotting out the line plots, let's say you plot out like 10 different zip codes, there's a whole bunch of ways you can plot it. Do you plot just the value? Do you plot how much the percent return from 1996? Do you plot percent changes per month to month, per year? There's a whole bunch of ways you can pull this out, and you have to decide what's the best thing to kind of pull out from this information, okay? And then once you have this part, you get your zip codes, you make your decisions, you're writing your markdown stuff, explaining why you chose these zip codes. In my opinion, you would get down to like about here and say, okay, I have these 5 zip codes. Let's go ahead and try doing a modeling on this. And note that here they talk about ARIMA. You could, for example, use, you could try using for Surima Max, for example. I see that quite frequently. Note, however, this probably won't have seasonal information as much. So ARIMA model will probably be just as good. But if you want to follow along on the curriculum for one of the labs, you could probably do that. And just know that the seasonality is not going to be a huge importance to it. And that also I've seen people use Facebook Profit. Any of those parts, modeling will be important. So just know that when you're doing this modeling, you still want to have that narrative going forward. Note that this modeling, like it's kind of funny that there's like these like little empty cells, because I guarantee this is going to be one of the hugest parts of your thing, because looking at each zip code, doing a modeling, filing the model, and then doing diagnostics of your model, and then explaining like how that looks, and possibly not even just doing, if you did like, for example, stepwise, like finding the parameters that are for different models. If you compare not just the best, like lowest AIC, but maybe the second lowest AIC. So that was going to take up some space. Note that this will take some time. That's why I highly suggest making some functions. Otherwise, you're going to be copying and pasting a lot of codes and cells over and over again for each zip code. And then finally, you're interpreting results. Make sure you have, okay, now you got all this stuff. What does this mean for the business? Like, what should they do? And say, what can they expect? So what are your recommendations? Like, for example, if you find your 5 best zip codes, why did you choose those 5 best zip codes? What makes those important to the stakeholder? Are they all the same? Are they different? Do they balance each other out? Like, what that stuff? Basically your conclusion here. And then saying, what kind of expectations can I do from the modeling? And, you know, if the model doesn't do as perform, make sure you note that. Say, hey, like, even though we predict it's going to perform this well, know that this is our confidence in here, and maybe there's other things you can do, which is going to be something like future work. Say, okay, like, how would we go further into this to explore deeper and stuff like that? And so hopefully that kind of gives you a good idea of like how this kind of all comes together. But the main focus I really want to put in is like, most of your time, in my opinion, it really should be focused on how do you choose your zip codes? And then your modeling aspect should take maybe like at most like a third of the time, if not like a quarter to a third of the time, maybe done in the modeling. You shouldn't focus too hard on this part, because quite honest, there's a lot of, as a data scientist, unless you go to a very specific field, you might not be doing this modeling very often. But it gives you a nice competitive advantage as well, saying you're familiar with this aspects and understanding the concepts of these modelings and what kind of like parameters are being put into it. So if you were needed to go into this, you could explore further or ask someone, or basically say you have some general knowledge in this area. Okay, cool. That's kind of like a very like relatively brief overview of this project and like the parts that I suggest and stuff. Do you guys have any questions?
I do. So yeah, I'm gonna ask about the train test split on this model. Should we care? Should we just use the whole data to do the forecasting, or do we need to do the train test to see if it works okay?
Yeah.
Or, and also, like, should we do that at the beginning? I mean, you know, as as the whole modeling process, or at the end of everything, just to see if it's okay?
Okay, no, that's good. And I think overall, I will say for any machine learning part, for all data science, everyone should really know is always be aware of that train test split. In fact, I really call it your train dev test split, where essentially you have your training set, your dev, your validation set. So dev or validation set, and then your testing set is kind of like your final, like, what's it called, like comparison. In this case, the way I would suggest splitting this is, first of all, look at all the data for what it is, like what it looks like. But usually in time series, what you typically would do is you essentially want all the data you can from the past, right? At least that's relevant to your model. And so you essentially will say, okay, let's say 1996, 2018, you cut off maybe the last 2 or 3 years or some kind of portion at the very end and say, okay, I'm only going to train it from, let's say, 1996, 2015. And you train it on that data. Then you take your model that's already trained now and perform and see how well it fits compared to your 2015 to 2018 or whatever you stopped at, right? And say how well that performed. And that's essentially your validation, right? And then in reality, what your test set would be if you did this in real life is you would say, okay, let's go ahead and input it from 2018, your most recent data, and say how will it perform in the future and make predictions off of that and see how well it performs. And that way you can kind of still have as much training data as possible to train your initial model, see how well it performs, and then using all of this info to predict it in the future. Does that make sense?
Yeah. All right. Is there a, other than just a visual indication on that train test, I mean, just a test and forecasted data on the plot. Is there a way that we can just, you know, like use MSE or standard deviation, you know, like how do they relate it in terms of, I mean, how can we standardize the accuracy of the model? I mean, without, if we just don't see the plot at all. Is there a way we can
Yeah.
just, you know, just like, you know, percentage or accuracy, something like that? Is there such thing?
Yeah, I would. So first thing I will say is that visualization is always an important aspect that I always recommend anyone, no matter what kind of model it is try to do some visualization to help you get an idea of how well your model is performing. There's a bunch of ways you can do that. But I would say like MSE would probably be a good kind of way to kind of factor in about how much it is. No, I think the curriculum mentions about just doing the MSE, but I think the curriculum goes like the squared residuals, doing the average, but it never takes the square root of it. So note that like there's a lot of people who say like, oh, because the value is relatively high, you'll get something like literally like in the billions or trillions in like your MSE. If you take the square root, that will give you a more realistic of like how different you were from that point. So just kind of be aware.
My question is, that is like, what's the standard? Like, should we, I mean, that square root MSE would be like any number. In this case, it's a big number, like something 800 or something. So how can we interpret that number? Like, shouldn't we just compare with like standard deviation or something like that, so that we can have an idea, some sort of like normalized?
Okay, I think you're saying like, how do you know, like more standard? And I will say is that the mean squared error really emulates what standard deviation is doing, since it's basically doing the squared difference and then summing up and averaging it. That's literally what MSE is kind of doing. So obviously the scale will be different, right? So that's the big thing.
Yes. The scale is big, yeah. So how can I tell that, oh, okay, this is a good number or this is a huge number?
It's honestly a little bit of context of like, how much are you willing to like say is a good model versus a bad model, and also seeing like what other things do. Like in industry, if you were to say, hey, is this a good model or a bad model, you would see, well, what's the typical, like what have other people been able to achieve, and what is like the most recent research on this, like, you know, like being able to predict it from this area. And if you can do better than that, you're like, cool, that means I have a really great model. If they're lower than like what other people are doing, you might need to go back to the drawing board a little bit and say, okay, well, how can we improve this model? So a big part of it is doing research to say what the expectation is. I would say if you're able to get within even like this value is going to be pretty large, but 50,000 after doing the square root of your MSE. So like basically your standard deviation is equivalent to like 60 or 50,000. I would say that's a pretty good model for this project, considering the resources you guys have.
Okay.
Does that make sense?
Yeah, definitely. It makes sense. It's just, I just wanted to know if there's like a standardized way to compare these things. So
yeah, your mean squared error.
I see. All right, thank you.
Because like I'll just kind of emphasize. That essentially is your MSE right there, right? If you're taking the difference between your prediction, this case is the average, but basically you have like your, what's it called? Your actual value, your predicted value, you square it basically, and then take the average of it. Well, that's what essentially divided by n, and then taking the square root of that, that is your standard deviation essentially. So note that that's why kind of like why that mean squared error is basically related to your standard deviation.
Okay.
Does that make sense?
Okay. Yes, thank you.
Okay, cool. But good question. There you go. See, almost identical. Okay. Any other questions you guys have? Okay. Sound pretty good? Okay. And note that, you know, next week will just basically be for our full-time cohort. It's just going to be office hours for our study groups. Phyllis, if you have more questions too, you know, if you're working on that project, I know you're self-paced, right? So you're welcome to kind of come in our office hours too.
Yeah, I just really want to move on. It's been it's been 3 weeks I've been stuck in this project. So
it can be really tough too. So yeah, definitely reach out if you have other questions. One thing I'll kind of note, I've told people in the past, is that I think this project in particular, it's not so much that this project is necessarily hard. I think it's that the expectations for people are higher than what is needed for this project. I think the thing that holds people back for this project is thinking it needs to be better. So you might already be at this level and not realize it yet. So if you have a chance to talk with an instructor, kind of show what you have a little bit, say, hey, does this look decent, or any suggestions without doing a full assessment, that might be an option. Check out and stuff like that.
Well, it's actually kind of confusing. It was because the most of the part is just selecting those zip codes that and I just had this question in my mind. If I can just select the top best zip codes, just filtering them with different parameters that I created, why would I just model? Just give the 5 zip codes. It was kind of really confusing to understand the expectation. But I think just I got it now. Thank you.
Okay, no problem. Yeah, and I think that's can be a little confusing too, because the first thing I say, why don't I just model everything and then pick the best zip codes from the modeling, right? And the real reason why it's because you usually don't have the resources to actually do all the modeling.
Try that. That's just
it won't go well. I've seen ways you can do it, but it's not the main focus of this project. And I think in reality, it's not what you likely would do as a first initial step, which is what this is, considering like the expectations of 40-hour, week dedication for a project. So yeah. Cool. Awesome. All right, everyone. Well, if you guys do you have any last questions? Otherwise, I can let you guys go.